Hello. Yeah, I think my audio should be audible. I should be audible to you now. Hello, hello. Okay, perfect. Uh, okay, so we are gonna be solving Codeforces round 729 today. Okay, and I will be solving problem ABCD today of this round. Okay, just a second. Should I edit the? Okay, let me at least edit the title of the video that people know I'm gonna solve ABC. Okay, first I wanted to know like how many problems you all were able to solve. Okay, let's see. Today's contest was more about observation. I think like A, B, C, D, all four questions were all about observation only. It says A, B, C, the one says A, B. Okay. Okay. 3. Sudadeep, C. Sudadeep says 3. Sachi says 3. Okay, perfect. Perfect. Okay. I think we can start now. As usual go in order only from A, B, C, D. Okay. And let's start with problem A. Okay. All right. So, problem is says that you're given a palindromic string s of length n. You have to count the number of indexes I such that the string after removing si from s still remains a palindrome. For example, consider string s equals to aba. Okay, so we have aba. Okay, a, b, and a. Okay, if we remove si from s, s1 from s, the string becomes ba. Okay, so this becomes ba. This is a palindrome already. Okay, ba is not a palindrome, so this is not possible. Removing this a is not possible. The next case would be if we remove this b. If we remove this b, it becomes AA, which is a palindrome. So one case. The third case would be removing this a, which would actually make what? AB, which is not a palindrome. So there is only one case in which if we remove any one character from the given string, it still remains a palindrome. Okay. So the answer for this ABA would actually become A. Okay. So what we are given is we are given a string and we need to find out how many such indexes are present. If we remove those index, that one index for that one turn, okay, the string still remains a palindrome. Okay, so for example, this ABA is done. Let's take this one. Okay, so if we have A, C, then 4 times A, then CA. Okay, now if you see, if you remove this A, this string becomes C, then 4 times A, CA, which is not a palindrome. Similarly, if you remove this A, the string becomes what? AC, 4 times A, and then C. Again, not a palindrome. Similarly, for the C also, if you remove this C, your string actually becomes 5 times ACA, which is not a palindrome. And similarly, if you remove this C, it becomes AC 4 times A, and then again A. The C is removed. Again, this is not a palindrome. But if you remove any one of these 4 A's, so if you remove, let's say the first A, it becomes AC, then 3 times A, then CA. Or the same string would have been made if you had removed this A or this A or this A. Which means if you remove any of these 4 A's, the string still remains a palindrome. So the answer for this string is 4. And by this you must have got the idea also that all you have to do is just look for the center element. Whichever is the center element, just see how many same characters are present on the left side and the right side of it, and that is the answer. Okay, now for an odd case it is easy. Okay, for odd we know that like if it's an odd value, we know that the middle one will be the center value. But for an even value, you can take either this one or this one, no matter, and that's it. Okay, so that is all you have to do. Okay, and I'll show you the code as well. Pretty simple. Okay, how do I? Okay, just yeah. Cool. Okay, so all I did was I just found out the index of the center element, which is n by 2. Okay, then I ran from index in the left side. Okay, and so how many values have the same value? Count plus plus and then break if it's not the same value. Similarly on the right side also from index and then count minus 1. The reason I'm doing count minus 1 is because I'm counting index twice, here and here. Okay, so that's all you had to do for problem A, and I'm pretty sure like almost everyone was able to do problem A. Okay, and let's move on to problem B now. Okay, cool. Can I have a yes from everyone if they are able to solve A? Like if now at least after solution. Okay. All right. Moving on to problem B. You're given a permutation P of integers 0 to n minus 1. Okay. Uh, yeah, n minus 1. Each of them occurs exactly once. Initially, the permutation is not sorted. Pi is greater than Pi plus 1 for at least one. The permutation is called x sortable for some non-negative integer x if it is possible to sort the permutation by performing the operation below some finite number of times. Okay, choose two indexes I and j such that Pi and Pj, this is arithmetic and of bitwise and of Pi and Pj, that should be equal to x. If that is equal to x, then swap Pi and Pj. And using this operation, you have to sort the complete array. Okay. Now, okay, so we are given a permutation from 0 to n. Okay, so we have permutation. Okay, from 0 till n minus 1. Okay, and we need to sort this such that Pi and Pj, this should be equals to x. Okay, we need to maximize this x. Okay, maximize. Now, let's look at some test cases. Okay, let's look at the very first test case, which is 0, 1, 3, 2. 0, 1, 3, and 2. If you see, 0 and 1 are already sorted. So the only two values that you need to sort are 3 and 2. Okay. Now, since these are the only two values, we can just find the AND of these two values only, which is actually 2, and that is the answer. Okay, because in order to sort these two values or swap these values, you need to have the mod of these two, bitwise AND of these two values, which is 2. Coming on to the next case. Okay. So the next case is, okay, the next case is 0. Okay, it's 1, 0. Okay, now again for 1, 0, these two are to be sorted. So just find arithmetic mod of bitwise AND of 1 and 0, and this is 0. So the answer is 0. The next case is 0, 1, 2, 3. Okay, it is, let me just remove this. So we have 0, 1, 2, 3, 5, 6, and 4. If you see 0, 1, 2, 3 are already sorted, so no need to disturb these values. 5, 6, and 4 are not sorted. Now what you want is, you need any two values which you can pick up so that you can sort those two, like swap those two values. So you want to pick up 5, 6 also. At some point you might have to pick up 6, 4 also, and you might have to pick up 5, 4 also. Okay, and every time when you pick two values, their AND should be equals to x. That means 5 and 6 should be equal to x, 6 and 4 should be equal to x, and 5 and what? 6 should also be equal to x. Okay, and this is only possible when the AND of 4 and 5 and 6 is equals to x. So all you have to do is look for all the values which are not on its sorted place, find the bitwise AND of all those values, and that is the answer. Okay, if you look at the last input as well, if you see, we are given 0, 3, 2, 1, and 4. Now if you see, this 4 is already at its sorted place, this 0 is already at its sorted place, 1, 2, and 3 are not at its sorted place. Sorry, 1 and 3. 2 is also at its sorted place. 1 and 3 are not at their sorted place. So you have to find the bitwise AND of 3 and 1, which is 1, and that is the answer. That's all. That is all you had to do. Okay, let me just show you the code as well. Okay, so this is how I coded it. First, I scanned the complete array. Okay, I made another copy of the array with the name array1, sorted the complete array. Okay, and then just saw which all indexes are not at its right place. Whichever indexes were not at its right place, I inserted them into a vector, found the bitwise AND of the complete vector, and returned the answer, and that's it. Okay, So that is all you had to do in this problem. Okay, again, a pretty simple problem. Sahil says, how do you know these properties? I'm never able to do bitwise questions. Honestly, I myself am not very good at knowing bitwise properties and doing bitwise problems. But this is something very general which you should know. And yeah, I think like this all comes with practice only. Maybe you can go to Geeks for Geeks. There is a section with bitwise manipulation, and you can read that, the blogs of that section. I have never read that. Okay, but yeah, I have to read them at some point. Maybe that will help. Okay, cool. Let's move to problem C now. Could it not happen that A and B is equals to X? B and C is not equals to X, but A and B and C. Yeah, that can also be happen, but you will still see that there are some pairs which you can do through which B and C are also possible. I was not able to do a problem also. What to do? I don't know what you're trying to say, Ormo. Okay. Anyways, let's move to problem C, which is LIS or reverse LIS. Okay. Okay. I hope everybody knows problem A and B by now. If you still don't know how to do this, just tell me. Okay. And give me a minute. How many were able to do problem C? C is an interesting problem with just one edge case. Okay. Okay, cool. I think we can start with problem C now. So, in problem C, you're given an array A of n positive numbers. Okay, so we have an array A of n positive numbers. So, n values. Okay, all positive. Okay, cool. Now, let LIS A denote the length of the longest strictly increasing sequence. Okay, LIS strictly. Okay. Okay, cool. Okay. Of A, for example, 2113 has an LIS of 2 because we have 1 and 3. Okay. And 3, 5, 10, 20 has 4. 3, 1, 2, 4 has 3. Okay, cool. Now we define A dash of the array. We define to obtain after reversing the array A dash equals to this. The beauty of array A is defined as minimum of LIS A and LIS A dash. Okay. Your task is to determine, just a sec. Yeah. Your task is to determine the maximum possible beauty of the array A if we can rearrange the array A arbitrarily. Okay, cool. So let's for once forget that the values are not distinct, because if you see in this, we can see that the values are not distinct. Okay. Let's assume that the values are distinct for now. Let's say we had numbers till 1 till n. So let's say we had 1, 2, 3, 4, 5, 6. Okay. If we had all these numbers, okay, or let's take 5 only, till 5. If we had 1, 2, 3, 4, 5, what is the maximum LIS we could get? Okay, in the from left to right and right to left, such that the minimum of left to right and right to left is maximized. Okay, so if you see all the values which you are taking from left to right in counting LIS won't be used in this right to left. Okay, so what you can do is, the best way to do this would be, if you see 1, 2, 3 and you have what? Sorry. If you have, we need a longest increasing. Okay, how do we make this? It is made using 5, 4, 2 and 3. Now if you see, if you go from left to right, we have 1, 2 and 3. And if you move from right to left, we have 2, 4 and 5. So from left to right, we have an answer of 3. From right to left, we have an answer of 3. Minimum of 3 and 3 is 3. So the answer is 3. And if you see, this 2 was common. We use this 2 from left to right as well and from right to left as well. Okay. Let's say we added 6 as well. If we added 6 as well, we know we can take half of these values from left to right and half of these values from right to left. So left to right, let's say LIS of A would actually be 6 by 2, which is 3, and the LIS of A dash would also be 3. Perfect. Now, let's see what happens when we have multiple values. Okay. Now, if you see, if we had, okay, let's take till 5 only. Let's say this was present. Okay. And the array was what? This. Now, let's say we had an additional 1. If we had one additional 1, we know we use this one from left to right. Now, since we have one more 1, we can actually use this one from right to left as well. So, we actually add 1 in the end. Now, from left to right, we have 1, 2, 3, but from right to left, we have 1, 2, 4, and 5. But if you see, there is no point of increasing any more count of ones, because let's say if we added one more 1, if we add it on the left side or on the right side, it won't make a difference because this one is counted in both the directions already. So if any value has a count greater than 2, that is of no use. Okay, we only want values which have a count less than equal to 2. If any value has count greater than 2, that is of no use. Like, we just have to assume that its count is equal to 2. Now, if any value has their count equals to 2, or not equal to, greater than equal to 2, then we actually need to count this both sides. Okay, count both sides, because one value will be used from left to right and the other value will be used from right to left. But if the count is only equals to 1, then you can either take it on the left side or on the right side, except one value which you can actually take common. Okay, so the very first thing that you have to do is you have to find all the values which have a count greater than equal to 2. Which all values have their count greater than equal to 2, make that answer. Okay, now if the number of values with count equals to 1 is greater than or equals to 1, then first do answer plus plus, because that one value will be used. Okay, and then add count minus 1 by 2, because half of the values will be used on the left side and half of the values will be used on the right side. Is this clear to everyone? Like, it's all about observation only again. Okay, there's no particular logic of this one. It's all about observation. Like, you just observe and see like how the array is going to be arbitrary arranged, and then you do this. Okay, so is this clear to everyone? Yes, bhaiya. Okay, cool. Okay. Yes, Abhinav says yes. I'm not able to do even the contest. Any suggestions? Keep practicing. That's the only suggestion. Like, I don't really know like how much you practice, but if you practice like long enough, I'm pretty sure like you will be able to start doing problems. Okay, cool. Bhaiya, can you explain this problem again? Okay, I'll explain this once more. Okay, let's say we only had unique values. If we only had unique values, we could take half of the values on the left side and half of the values on the right side. Okay, except one value which you could use as a common value. So we use this 2 common value here. Okay, we had 1, 2, 3 on the left side, and from the right side we had 3, 4, 5. So this 2 was used in common. Now let's say we had 2 ones. If we had 2 ones, we could use one from left to right and one other one from right to left. So from right to left now we have 1, 2, 4, and 5. Okay, similarly, all the values which have a count of greater than equal to 2, one occurrence of that can be used from left to right LIS, and one occurrence of that can be used from right to left LIS. Okay, all the values which have a count equals to 1, one out of all these values can be used as a common value for left to right and right to left. Okay, so you do answer plus plus. Your answer is initially equal to count of these values. Okay, then you do answer plus plus, and then you add count minus 1, because one value has been removed which is the common value. Count minus 1 by 2. because half of these values, half of the rest of the values of this will be used from left to right, and half of the rest of the values will be used from right to left, and that's it. Okay, Ankit Kumar, bhaiya, I did the sorting and sent values to two set, namely set 1 and set 2, take the minimum of size of both, but I got error. I don't really know like what you did. Which related problem you suggest? Okay. Write a Python problem to reverse the line order of text when write the. Okay, cool. D बताओ जल्दी टाइम नहीं है. Start solving. Okay, भैया I did the. Ankit, I'm not really able to understand like what error you are getting. Okay. Can we binary search? I don't see the point of doing binary search actually. Okay, we might be able to do like even after doing binary search, let's say you took the mid value, you will have to see like if it is possible to have LIS equals to mid. Okay, from left to right and right to left. So I don't really know like how you would do that. It might be possible, but I don't really see the point of doing it complicated. Okay, let me show you the code as well. Okay, cool. So this is the code. Again, pretty small code. Okay, so all you have to do is first count the occurrences of every value in the map. Okay, then I'm just checking all the occurrences, all the values which have a count greater than equal to 2. I increment my answer, and all the values which have their count less than equal, like less than 2, which that is like their count is equal to 1, I'm just putting them all the values in the count. Then what I do is, if this count is greater than 0, that means all the values which have their occurrence equals to 1, if they are greater than 0, I increment my answer because this value will be my common value. I decrement my count, and then I do count by 2 because half of these values will be used on the left side and half of these values will be used on the right side. That's it. That is all you have to do, and with this like after this you just print the answer, and that's it. Cool. I hope problem C is also clear to everyone. If it is, we can move on to problem D now. Okay, how many here were able to do problem D? Like, is there anyone who was able to do problem D? I almost did problem D. Okay, I actually thought of a very complicated approach. Tried to code it, wasn't able to code it in time. Although the approach is perfectly right. Okay, but then I actually saw some people's solutions. Okay, like how the other people did it, and like there is a very simple observation that you have to do in this problem, and like the you can then solve this problem in like 10-12 lines. That's it. So like again, D is also an easy problem only if you just like observe. Okay, I'll tell you both. Should I tell both the observation, like my observation, like how I did it, and how like the easier observation as well? Okay, I don't see people liking the stream. I only have 30 likes. 46 people are watching the stream. Can you please like the stream so that I know like this is helpful. मैंने try किया but नहीं हुआ. नहीं सर D कर लिया होता फिर तो अभी Google में होते. Okay, नहीं ऐसा कुछ नहीं है. Like even if you are able to do D, that doesn't mean you will end up in Google. Okay. Let me see how much +1 I'm getting. Oh, I'm getting only +1 rating. I actually thought I would become CM today. I am just how much my rating right now is, I think 1874. Yeah, okay, this got increased 1874. So I thought like I would reach CM today. I could have done D if I had like 5-10 more minutes. But yeah, let's see. We have a contest tomorrow as well. So hopefully tomorrow, let's see, or not maybe. Okay, anyways, let's move to problem D now. Okay, let's see what the problem is trying to say. There are n nodes arranged in a circle. Okay, we have a circle with all n nodes from 1 to 10 in clockwise manner. You are also given a binary string S of length n. Your task is to construct a tree on the given n node satisfying the two conditions below, or report that that such tree does not exist. Okay, so basically, for each node I, the degree of node is even if Si equals to 0 and odd if Si equals to 1. Okay, no two edges of the tree intersect internally in the circle. These edges are allowed to intersect on the circumference. Okay, all you have to do is make n-1 edges such that the complete circle becomes connected. No two edges intersect each other, and if Si is equals to 0, then that means the degree of that node should be even, and if Si equals to 1, then the degree of that node should be equals to odd. That's it. All right. Now, okay, cool. Let's look at the test cases. Okay, I'll first make the first test case. So we have 4 nodes, 1, 2, 3, and 4. Okay, 1 should have even edges, 2 should have odd edges, 3 should have odd edges, and 4 should have even edges. Okay, now how to do this? One possible answer for this would be, okay, one possible answer would be we connect this 3 with 2 with 1, we connect this 3 with 4, and we connect this 1 and 4. With this, 1 has an degree of 2, 2 has an in degree of 1, 3 has an degree of 1, 4 has an degree of 2. Okay, and like no edges intersect and everything, so this is the valid answer. For the next case, we don't have any valid answer, so I won't take that. Let's look at the last test case as well. We have 6 edges, 1, 2, 3, 4, 5, and 6. 1 should have odd edges, 2 should also have odd, this should have even, this should have odd, then again this should have odd, and this should have even. Okay, now let's see how, like, let's try to make a valid answer for this one. Okay, a valid answer for this one would be this and this, and then all you have to do is this, this, and this. Now if you see, this one has an degree of 1. Okay, so perfect. This 2 has an degree of 1. Perfect. This 3 has an degree of 4. This 4 has an degree of 1. Perfect. This 5 has an degree of 1. Perfect. This 6 has an degree of 2. Perfect. Okay, so this is one valid answer. The number of edges we have is 1, 2, 3, 4, 5. 5 edges. Okay, so n minus 1 edges. No edges intersect. So this is one valid answer. Now, how to come up with this answer? Let's see. First, see which all cases will have an answer is equals to no. Okay, how do you see that? Let's see. Okay, so now let's see. Let's take this string. Okay, and let's say the number of ones we have are x and the number of zeros we have are y. This one is nothing but odd in degree. Okay, and this 0 is nothing but even in degree. Okay, using this, let's calculate the complete in degree count of the complete like graph or tree. Okay, since 1 means odd degree, that means all the nodes which have 1 will actually have 1 degree. Let's assume the least in degree only. So every node which has 1 means they have 1 edge going through that. Okay, so 1 edge, that means x number of edges. Okay, for y we actually need 2 times, sorry, 2y, because if a node has 0 in degree, okay, not 0, like even in degree, that means 2 edges are coming towards it. Okay, if this is the node, 2 edges are coming towards it. Okay, so 2y, and if you see, this is nothing but total number of edges. Like this divided by 2 would actually become the total number of edges. Okay, this is only possible when this x is even, because if this x is odd, then we cannot divide this by 2. Okay, so that is the only case in which we get an answer of no. Like if the count of x is odd, like if the count of x is odd, then the answer is no. If it is even, then yes. If this is odd, then it is no. Okay, so this is the only condition when the answer is no. Now let's move to when the answer is yes. Okay, so now this problem is all about observation actually. Okay, so I have two approaches for this problem. One is very easy and the other one is difficult. I will explain the easier version first. Okay, so let's see. Let's say a complete cycle was, okay, what I'm actually going to do is, O means a node with odd value. So O means node with odd degree, and E means node with even degree. Okay, now let's say we have an odd degree node here. Then we have some even degrees. Then again we have some odd degree. Then again we have some even degrees. Then we have an odd degree. Then again let's say we have an odd degree. Then we have some even degrees. Then again an odd degree. So we have what? 4. Then even degree, and then again let's say an odd degree. Let's say this was the complete cycle. What you can do is take this odd degree and connect with this odd degree with all the values of even. So basically like connect this, and connect this. Let me use a black marker. So connect this, connect this, connect this. Now if you see, this O is satisfied. It has one end degree and it wanted only odd end degree, so this is satisfied. This even has 2 end degree, so this is also satisfied. This even also has a 2 end degree, so this is also satisfied. Only this value is left. Now let's come on to this odd. Let's connect this with this one and this one. So connect the odd and the even consecutive values. Now if you see, this odd is satisfied because it has 1 end degree. This even is satisfied because it has 2 end degree. Okay, this even is not satisfied, so this is left. Again come on to this one. Now since this odd has no even degree values here, so don't connect this with anything, so this is left. Okay, directly come on to the next node. This odd has some even values after this, so connect them. Let's connect these. This is satisfied, this is satisfied, this is satisfied, this value is still not satisfied. Again, for this odd, connect this with this even. This odd is satisfied, this even is not satisfied. Okay, again after this odd there is no even value, so this odd is also not satisfied. Now if you see, we have 6 nodes which are not satisfied. Okay, but if you see, every node needs one more additional end degree. What you can do is take this even and connect this with this. Now this is satisfied, this is satisfied. Again take this value and connect it here. Now this is also satisfied. Take this even and connect it with this one. Now this is also satisfied. Take this even and connect it with this one. Now this is also satisfied. Okay, take this even and connect it with this one. Now this is also satisfied. Okay, now how many end degree does this node has? 1, 2, 3, 4, 5 and 6. 6 end degree, so this is also satisfied. And this is the complete answer. Now like let me just prove like why this works. Okay, so what we initially did was we took every odd value. Okay, we took every odd value, connected it with all the subsequent even values. So let's assume I have a set here. Okay, let's assume I have a set here. This has odd some number of even values. Okay, I know the number of nodes with odd end degree is x. Let's say this is x. The count of all the nodes with end degree odd is x. That means I will have x number of sets. 1, 2, 3 going on till x number of sets. And in every set, my last node won't be satisfied. This was not satisfied, 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 this was not. So every last node was not satisfied in the set. So all the last values won't be satisfied. What I have to do is take the first set, take the last value of the first set and attach it with all the other sets. Now if you see, this node, okay, this node already had an end degree of 1 because it was connected to its previous value. It is connecting with all the other sets. How many total sets we have? We have x number of sets. One set is this one only, so x minus 1 more edges are to be made. So 1 plus x minus 1, which actually means x only, and x is even, as we know that. Therefore this E has x number of edges outgoing from this one, and like this is satisfied. All the other nodes all the other nodes were not satisfied and wanted one more degree, which they are getting from this E. So they are also satisfied. Okay, and that is like the proof of this logic. Again, like pretty easy implementation for this one. I don't have the code for this one because the code I wrote is pretty complicated and it has a different logic, but I can show you somebody else's code. Okay, whose code? Let's see Jingli's code only. Okay, so I hope everybody is able to understand the logic. If there is anyone who is still not able to understand the logic, do let me know. Okay, otherwise I can just tell, like, give you a like walkthrough of the complete code. Okay, is there anyone who still doesn't understand like how to solve this problem? What expected rating of task D, sir? I think it's somewhere around like 1700, 1800. Like it doesn't really have any algorithm or anything. It is just observation. That's it. And I'm pretty sure like there are multiple observations for this one. This is one easy observation. There is one other observation that I know. Okay, but it's difficult to implement that. And like there might be other observations as well for this one. Okay, is everybody clear with the approach, or should I like explain it again? Okay, cool. Let me just why I keep making these videos. Okay, cool. Let me just explain the like show you the code as well. Okay, so okay, this is Zengli's code. Okay, I always look at his codes of every problem. Like I think like he writes very easy and like very nice implementations. Okay, okay. So let's see like what this person is trying to do. Uh, okay, so the very first thing that he's doing is actually he's just checking if the complete string has no ones. Okay, like the count of ones is zero. This is checking if the count of ones is zero or if it is odd. Okay, if it is zero or odd, the answer is no, as we discussed. Okay, then otherwise the answer is yes, so just print yes. Now what he is doing is he's finding the indexes of all the ones. Okay, he's finding the indexes of all the ones. That is exactly what we did. We found all the indexes of ones. Okay, in our approach also. Okay, after finding the indexes of all the ones, what he is doing is in this for loop he's just attaching all the subsequent even values together. So he is doing this part, like making these edges. After that, we know that every value before the next value is unsatisfied. So he's taking all those values in this one, okay, and just connecting all of them with the last value of the very first set. That's it. Like that is the complete code for problem D. Why CF rounds are becoming so observation based? Like you don't catch it and the whole contest goes bad. Yeah, like I don't know. Like though I love observation problems, okay, so I can't really complain for that. But yeah, I do feel like they're getting more into observational ones. Tomorrow we have, I think, an education round. I don't think education rounds are more about observation. They are, yeah, it's an education round. So like, probably this will be more like an algorithmic round. Okay, cool. So that is the problem D. I hope everybody knows how to solve problem D now. And yeah, that's it. I think that's enough for this stream. If anyone has any problems, they can ask me. Else, we can end the stream. I still don't see many likes. I only have 50 likes to the stream. Do like the stream, guys, and also subscribe to the channel. Okay. All right. So, should we end the stream? Does anyone has any problems they want to ask, or should I end? Okay. Okay. Let me read the chat. I skipped the chat. Okay. Okay, can we do wine research? Okay, what is your rating? पीयूष जीना नहीं सर, डी कर लिया होता फिर तो अच्छा, I read that. Kishore Jadoo, education round means indirect negative delta. Amazon London offer holder here. Okay, pro people here. Ansha. Okay. EF देखना है होंगे सर, डी देखना है. Okay, cool. Okay, how to increase rating? Keep practicing. That's it. Keep practicing. Keep learning about new topics. That's it. Like, don't rush for new topics. Okay, it's important to have a strong hold on all the topics that you already know and then move on to a new topic. Like, I myself don't really know like many complex topics. I know just the basic complex, just the basic approaches. That's it. Thanks for the explanations. Okay, thank you. Okay, I think I should end the stream. We have a contest tomorrow as well. The timing of the contest is just a sec. It's okay. It's no, yeah, it starts at 8 only. Okay, so I'll probably catch you all around at 10:30 p.m. only tomorrow as well. It's a Div-2 round again for all the people like less than rating 2100. And yeah, okay, see you around.